What is electric dipole? A system consisting of 2-point charges. I will fine-tune this definition later, but for now, understand. For now, this definition is correct. A system consisting of 2-point charges, equal in magnitude but opposite in nature, separated by a small distance. Tell me, why would anybody mention small distance right from the word go? I could have simply said distance. Correct? There has to be a purpose in saying small distance. And I'll tell you what the purpose will be. So in your slides, you have a minus q, you have a plus q, and you have a distance between them as 2a. Sir, why 2a? Why not a? So that the midpoint can be broken down into a and a. I don't like fractions. If I divide it into 2 parts, it will be a by 2, a by 2. I don't like that. For my convenience, for my selfish nature, I called it 2a. So that 1/2 is a, 1/2 is a. You have a problem? No. Perfect. So you have a minus q, you have a plus q. The color coding of positive is blue. The color coding of negative is a little peachy pink color. Can you see? This arrangement is electric dipole. Hold on to your question, sir. Why? Why are we studying this? What is so special about this arrangement? Hold on. I will answer that. Before I go ahead and answer that question, let's understand some terms which I'll be using very frequently out here. Okay? First term, axis. Axis of the dipole. Can you see the plural axis? Honestly, I have no idea what you call it. Is it axis? It is axis? I don't know. All I know is plural is AXES, singular is AXIS. How do you pronounce it? It's your problem. So there are multiple axes, right? Axis of the dipole. The line joining the negative and positive charge is called the axis of the dipole. Means, if I produce this line, this line will be called as axis of the dipole. So now on, if somebody uses just the word at the axis, we should know we are talking about the line joining the charges. Okay? As promised, there are multiple axes. Equatorial line. The line perpendicular to the actual line. The perpendicular bisector I was talking about. And see, half and half is a and not a by 2 because I don't like fractions. So for the wholesome value of a, I chose the distance to be 2a. Each one gets a. And this line, guys, which is dividing the axis into equal halves, is called equatorial axis or equatorial line. And in some books, I have seen it to be referred to as just equator. Got it? Perfect. In fact, not this equator line. Imagine a very sophisticated knife. What is the word for that knife which we use, the butcher's knife? There's some word for it, okay? That knife, okay? Imagine that knife is used to slice the line between them. Can you see the green plane? Sorry, the gray plane. The gray plane is actually slicing it in between. So the plane which slices something like this. If the stylus or the pen in my hand is actually what? The dipole, then my hand, my palm is the equatorial plane which is slicing it into 2 equal halves. In other words, equatorial axis, hold on the equatorial axis and stretch it both the sides. That's our equatorial plane. Did you understand that? Perfect. A plane perpendicular to the dipole axis and passing through the midpoint of the dipole. Got it? Shall we go ahead? Perfect. After having defined axis of the dipole and equatorial axis of the dipole, let's continue the trend in defining terms for the dipole. And in comes the most important term. I'm sure you have heard this term before, especially in chemical bonding chapter, dipole moment. Now, this is the moment when dipole moment comes into picture, and I will also use this opportunity to justify why electric dipole. Because I'm sure minus q plus q with a small separation, that can't be an agenda. I don't think that's the only reason why you're studying electric dipole. Why not 3 charges? Why not 4 charges? Where is the end? There is something more important, right? Focus. First, let's define dipole moment. Product of magnitude of either of the charges, that's q, and the separation distance between them, which is 2a in my case, is called dipole moment of the electric dipole. Okay? It is a vector quantity, right? And its direction is from negative q to positive q. Now, it's a vector quantity, so if you want, for the sake of completeness, I can actually make it 2a bar.